define the filters using that appropriate techniques. So two methods are available. One is image parameter method and insertion loss method. So out of the method, only insertion loss is very easy and it gives a practical solution. And we are not going to go for image parameter method. So based on that, we are going to design the four types of microwave filters. And after designing a filter, you have to perform frequency transformation, element normalization, and simulation of these elements, because we'll be doing all calculation at 1 radian per second, but the actual design frequency will be in megahertz and gigahertz. So you have to transform the frequency from 1 radian per second to gigahertz or megahertz. Element normalization, we'll take the R value to be 1 ohm, but actually we need 50 ohm. So you have to normalize that. And then you have to simulate to see whether what characteristics you require is actually got from the final design of your circuit. So design a prototype and transform the prototype to match your frequency and normalize the prototype to match your resonant conditions. So three things you have to do, and two types of filters are available: Butterworth and Chebyshev filters are available. Butterworth is going to be maximally flat, so that the required band of frequency, it is going to be having a flat response, and Chebyshev will be having ripples in the response, either in the pass band or stop band. So that's what you see here. We find all the elements assuming the cutoff frequency to be 1 and resistance value to be 1, but actually it will change. Butterworth, you see, maximum it will increase and then become constant. Chebyshev, you see, you have ripples in both stop band and pass band. So sometimes you have ripples only here and not here. Sometimes you have ripple only here and not here. So it depends on what Chebyshev type we are going to use. And how to find the element values is given here for Chebyshev and Butterworth. So we can use these formulas and find out the filter design parameters for Chebyshev and Butterworth. And this table will give you the values of GK, which are computed from the formula which is shown in the previous slide. So this is for Butterworth, this is for Chebyshev, zero point 0.1 dB ripple, for 0.2 dB ripple, and these are the normalization. So after getting the value of GK, you have to multiply by Z and divide by omega for L. Okay, same way, after getting GK, you have to divide by ZL and omega C for capacitor. This is called as frequency transformation and normalization of the values. So same way you see for high pass, low pass, band pass, and band stop, how the design is going to happen. Okay, and in band pass and band stop, you have one frequency called omega naught. Omega naught is going to be square root of omega 1 into omega 2. Omega 1 is the lower cutoff frequency, omega 2 is the upper cutoff frequency.